Okay. Before I continue, a student asked the 640 per millimeter per 4 is quite a large number. Yep. Okay. So what I did is I calculate the percentage of difference for not considering the T cube. So I took the second moment of area without the T cube, and then with the T cube and calculate the percentage. It is 0.063%. So that's why we can ignore the T cube only for that reason. Okay. Right. So we come back to where we were last. Okay. So what were we trying to achieve? Is we are trying to find the value of F1. Okay. We want to find what is our F1 value. So we have found our first moment of area in terms of Y. Then from there, we substitute into our shear stress equation. And then we are going to integrate the shear stress with respect to the area to find F1. Okay, so from here, this will be equal. So I'm going to carry on from there. I'm not going to skip step like before. I get lost, which I'm very embarrassing. So we're going to integrate a to a 4a squared minus by y squared, okay, dy. So the outcome is 4t over 2i. And then we're going to have 4a squared y minus by y cubed over 3. The limits is a to 2a. So this is equal to vt over 2i. So we will have 8a cubed minus by 8a cubed over 3 minus by 4a cubed minus by a cubed over 3. Okay, I hope I got this right. If not, it'll be embarrassing. Probably I was not awake earlier today. So you get 8 minus 8 over 3 minus 4 plus by 1/3. Okay, 8 minus 8 over 3 minus 4 plus by 1/3. So you get 5 a cube over 3. Okay, so this is our value for now. Okay, so then we are going to substitute everything. We're going to substitute everything inside. So what I'm going to do is I'm going to put I. Okay, I'm going to introduce I into our term. So we found our I. So it's Vt over 2. So our second moment of area, which we found earlier today, it is 28 a cubed t over 3. So 28 a cubed t over 3. Okay, then we're going to multiply by 5a cubed over 3 over here. Okay, so you can get rid of the t's. You can get rid of the a cubed. So this will be equal to 5 over 3. Divide by 2, divide by bracket 28 over 3, close bracket. So this will become 5v over 56. Okay, so we already found our F1. Okay, so F1, let me quickly remind you what we just found. We just found our value over here, F1, and it's equal to, at the same time, equal to F4. As I said, it's not difficult at all. It's real straightforward. Okay. So following from here, we have to determine our F2 and F3. So let me paste I have question from a student. Why is there a 2 in the equation? V over 2I. Samuel, are you meaning this 2 over here, Samuel? Where's Samuel? So that is why you have a 2 over there, Samuel. Okay. Okay. So the next one, let me copy this diagram again, so you can see better. So next, we want to determine. Okay, we like to determine F2, which is equal to like F3. So now you all get used to the procedure, right? So I will sketch out again. So now we have our point A to point B, and we like to see how you want to find from point B to point D. Yeah, or yeah, I can draw it this way. So now we are going to consider. Now we know that this area is a constant from point B to point D. So now we are going to find with respect to our Z direction. Okay. So if Z stops there, we have to consider this area also. Okay. We have to consider the area. So now we are going to like before, we have to find our QBD. So first moment of area. So this will be equal to your QAB plus by your QBD, which is going to be a function of Z. Okay, I'll put not a comma, but it's going to be a function of Z. So this value over here is a constant. Okay, that value over there is a constant. So I've not finished drawing my diagram. I do apologize. So again, this is our centroid. Okay, so the distance from here to here, we know that this is our 2A, and we know that the distance from here to the center. Okay, so I'm going to just quickly sketch the center. This is our A. Okay, so our QAB, we know that the width is T, the depth is A, and the distance from the Y bar is 3A over 2. Okay, then plus by Z, the width is Z, the thickness is T, and the Y bar is equal to A. So this will be equal to 3 over 2 A squared T, okay, plus by Z AT, okay, plus by Z AT. So I can take out the term AT, and then this will be equal to 3 over 2 A, or 3A over 2 plus by z. So like before, we found our first moment of area. Then we substitute to find our shear. Okay, shear BD as a function of z. So it's equal to V over IT multiply by AT 3A over 2 plus by Z. Okay. Again, we can remove our thickness. So it's equal to VA over I 3A over 2 plus Z. Okay. Then we're going to find our force from number 2. Why do we multiply QBD by Z? QBD. Okay. Why? Because this is the width. Okay, this is Z. This is our depth with T. And this is our Y bar. Okay, Jihan. I think you are okay. Yeah, Z is just a function. Okay, it's just a it's just a variable. It's a slider. Okay, it's just your variable. So from here, we are going to find. I'm going to copy this equation. Okay. So Z over here indicate that it's moving. Okay. Then from here, I'm going to find. I need this equation. That's why I copy it. So we are going to find our F2. Here we're going to determine F2. So F2 now is between the limits is 0 to 2A. Okay, and stress BD as a function of Z, and then we have to multiply thickness multiplied by dz. Okay, let me get the figure over, then you can see better what we are trying to achieve. Okay, so we are aware that the limits, the distance, which also is associated with the limits. The distance here is 2a. Okay, we are aware, that's why the limits is 0 to 2a. So from here, this will be equal to 0 to 2a. So we have VA over I. In fact, it should be square bracket. Do apologize. VA over I 3A over 2 plus by Z T dz. Okay. So we know that VA, VAT and I are constant. We leave it out. We just need to integrate 0 to A 3A plus Z dz. Okay, so I'll get this out. So very simple integration. VAT over I. So it would be 3AZ plus by Z squared over 2. 2A limits from 0 to 2A. Okay. So this would be equal to VAT over I So this is equal to 6a squared plus by 4a squared divided by 2. Okay. Wait, did I miss out anything? 3. Well, mistake again, Eugene. I miss out my 2 over here. Sorry. Always making the same mistake. Okay. So this will be equal to 6. Okay, so 3a divided by 2, 3az divided by 2, substitute in. Okay. So this will be equal to VA T over I, and you have 3a squared plus by 2a squared. So this is equal to VA T over I, and then you multiply by 5a squared. Okay. So again, we're going to put in our I value, which is 28 over 3. So 28 over 3, I think it's a cubed t multiplied by 5a squared. Okay, so you can get rid of this, get rid of this, get rid of this, get rid of this, get rid of this. So it's 5 divided by 28 over 3. It's equal to 15 over 28v. Okay, and this also corresponds